In 2017, our telescopes caught a glimpse of something truly extraordinary. A visitor from beyond our solar system. It was the first interstellar object we had ever detected. It was named Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. But what was it? This celestial traveler moved in a way that defied our neat categories, sparking one of the most exciting and contentious debates in modern astronomy. It was long, thin, and tumbling end over end, unlike any asteroid or comet we had ever seen before. Its trajectory was even stranger, as it accelerated away from the sun without any visible tail, a hallmark of comets. Was Oumuamua just a peculiar natural object, a shard of a shattered planet, or something far more profound? Could it have been, as some respected scientists have dared to suggest, a piece of technology from another civilization sent to probe our cosmic neighborhood? The mystery of Oumuamua began the moment it was spotted by the Pan-STARRS 1 telescope in Hawaii. Initially, astronomers classified it as a comet, but as they gathered more data, this classification quickly fell apart. Comets get their characteristic push, their non-gravitational acceleration. From ice turning into gas and jetting out when they get close to the sun, Oumuamua accelerated, but there was no gas, no dust, no cometary tail to explain it. The Spitzer Space Telescope stared at it, looking for the carbon-based gases you'd expect from a comet, and found nothing. This lack of a coma or tail was the first major piece of the puzzle that just didn't fit. If it wasn't a comet, then maybe it was an asteroid, just a weirdly shaped rock hurtling through space. But that didn't explain the acceleration either. Asteroids are slaves to gravity. Their paths are predictable, dictated by the pull of the sun and planets. Oumuamua, however, was giving a slight but undeniable push away from the sun that gravity alone couldn't account for. It was as if a gentle, invisible force was nudging it along its path, speeding it up on its journey out of our solar system. The mystery only deepened as scientists tried to understand its bizarre shape. Based on the way its brightness fluctuated, astronomers deduced it was highly elongated. Some models suggested it could be up to 10 times longer than it was wide, shaped like a cigar or perhaps a flat pancake. This is an extreme shape for any natural object. We've seen thousands of asteroids and comets within our solar system, and none of them look quite like this. Natural objects tend to be lumpy, potato-shaped, or spherical, due to gravitational forces and collisions over billions of years. Oumuamua's form was an anomaly. So if it wasn't a typical comet and wasn't a typical asteroid, what else could it be? The scientific community, dedicated to finding natural explanations, began to propose some exotic theories. One compelling idea was that Oumuamua was a nitrogen iceberg, a chunk of frozen nitrogen chipped off the surface of a Pluto-like exoplanet in a distant star system. As this nitrogen iceberg got closer to our sun, the solid nitrogen would have turned to gas, providing the gentle push. This process wouldn't necessarily create a visible tail like a water-ice comet would, because nitrogen gas is transparent. It's a clever and elegant solution that could explain both the acceleration and the lack of a visible coma. However, this theory has its own challenges. For a nitrogen iceberg to survive the long journey through interstellar space, it would need to be incredibly large to begin with, as cosmic rays would slowly erode it over millions of years. The number of Pluto-like parent bodies needed to produce such objects would have to be immense. Another naturalistic proposal suggested that Oumuamua was a hydrogen iceberg, an even more exotic concept. Solid hydrogen is extremely difficult to form and requires incredibly cold temperatures. While it could explain the acceleration without a visible tail, a hydrogen iceberg would evaporate so quickly near the sun that it would have had to be enormous to survive. And it would likely have never made it this far in one piece. This idea, while intriguing, is considered highly speculative by most astronomers. It pushes the boundaries of what we believe is possible in the universe. Then there's the possibility that Oumuamua was an unusual type of comet after all, one whose outgassing was simply invisible to our instruments, or happened in a way we didn't expect. Perhaps its chemical composition was unique, or the dust particles in its tail were too large to be easily detected. This is the safe explanation, the one that doesn't require us to invent new categories of celestial objects. But it still feels incomplete for many. it doesn't fully address the combination of all of Oumuamua's strange properties: its extreme shape, its tumbling motion, and its perfectly explained non-gravitational push. This is where the most sensational theory enters the picture, championed by Avi Loeb, a theoretical physicist from Harvard University. He looked at all the strange data points and proposed a hypothesis that others were hesitant to even voice. What if Oumuamua wasn't a natural object at all? What if its acceleration wasn't from outgassing, but from the pressure of sunlight itself? This phenomenon, known as solar radiation pressure, is a real and measurable force. It's the same principle behind the concept of a light sail, a method of spacecraft propulsion that uses a large, thin, reflective sheet to catch photons from a star-like wind in a sail. For solar radiation pressure to have a noticeable effect on an object the size of Oumuamua, the object would have to be incredibly thin and have a very low density. It would need to be essentially a sail. Loeb calculated that an object with Oumuamua's trajectory and acceleration could be a light sail less than a millimeter thick. This perfectly explained the gentle push away from the sun without any outgassing. It also offered a potential explanation for its extreme, flattened shape. An engineered sail would naturally be very wide and very thin. The implications of this theory are, of course, staggering. If Oumuamua was a light sail, it would be the first tangible evidence of a technological civilization beyond Earth. It wouldn't necessarily be a crude vessel, but could be a probe, a piece of space debris, or a navigational buoy from a long-dead or distant culture. Loeb argues that we should consider this possibility seriously, not dismiss it out of hand simply because it is extraordinary. He points out that in science, we must follow the evidence where it leads, even if it leads to uncomfortable or revolutionary conclusions. To him, the artificial origin hypothesis is not more speculative than the nitrogen iceberg or hydrogen iceberg theories. They all require us to imagine something we have never seen before. Naturally, this idea has faced significant pushback from the broader scientific community. The prevailing sentiment is that we should exhaust all possible natural explanations before resorting to an artificial one. Many astronomers feel that the nitrogen iceberg theory, while not perfect, is a far more plausible explanation within the known laws of physics and astrophysics. They argue that claiming it's alien technology is a leap of faith, not a scientific deduction. The principle of Occam's razor suggests that the simplest explanation is often the correct one. And for many, a weird natural rock is simpler than an alien spacecraft. The debate over Oumuamua is not just about one strange object. It's about the very nature of scientific inquiry. How do we balance skepticism with open-mindedness? When does an anomaly become evidence of something truly new? The controversy highlights a fundamental tension in science. Between sticking to what we know and being willing to explore the unknown, sadly, our window to study Oumuamua was incredibly brief. It was already hurtling out of the solar system when we found it, and it's now too far away and too faint for any of our current telescopes to see. We are left with only the data we managed to collect in those few short weeks. It's a cosmic cold case, a mystery with clues that can be interpreted in wildly different ways. Perhaps one day we will find another object like it. The Vera C. Rubin Observatory, set to begin its survey of the sky, is expected to find many more interstellar visitors. If we find more Oumuamuas, and they all share these same strange characteristics, the case for a new class of natural object will grow stronger. But what if the next one we find is transmitting a signal? Or what if we never see anything quite like it again, leaving Oumuamua as a unique, baffling enigma in our astronomical records? Ultimately, Oumuamua forced us to expand our imagination. Whether it was a shard of an exopluto, a hydrogen iceberg, or a piece of alien technology, it proved that the universe is more complex and surprising than we ever thought. It was a messenger, just as its name suggests. But the message it delivered is still being deciphered, and its true meaning could reshape our understanding of our place in the cosmos. Thank you for joining us on this journey to the edge of scientific possibility. If you find these cosmic mysteries as fascinating as we do, be sure to subscribe to Space Repo for more deep dives into the wonders of our universe.